Okay, so um, today I would like to start with the calculus on the parametric curves. Yesterday we have learned a little bit, but let's just take slowly. Let's take slowly. So let me just review a little bit on last questions and how we deal with the tangent. So let me just a little bit review what we have. Okay. So the parametric is basically just adding additional variable. Okay. So we have an x, y as our usual in Cartesian, and we add another variable which we call the parameter, right? Or we say t. The symbol is t. Okay. So the idea, okay, what you need to remember as a principle in the parametric. Okay. So the x is a function of t, y also a function of t. But we also need to establish one assumption that y also a function of x. Okay. So y can be a function of x, it can be also a function of t. Okay. That's why when we deal with the first derivative, where we would like to find dy over dx, this is, let me just rephrase this as, this is the first derivative of y with respect to x. Okay? Basically, this is just a derivative and making this f prime x, right? But we need to make this structure now in terms of t. So we need to connect all of them with t. That's why we are going to have this chain rule. Okay? And from this, we get that, okay, dy over dx is just dy over dt over dx over dt. Okay? At a glance, at a first impression, you might think, if I have this, and I will differentiate one more time, oh, perhaps this will be differentiate one more. It seems like that. But in truth, because of the relations that the function at the beginning has, that the x is function of t, y is also function of t, but y also function of x. That's why we cannot differentiate this one by one. Okay? What we need to do, however, we need to make sure our definition is correct. Okay? That's why this way here, this is not the correct way. Okay, so let me, do I have the stickers? Let me take the stickers. Where's my sticker? Okay, no, okay. Okay, I forgot that I have sticker. This is me. Okay, so this is not correct. So the way that we need to take this as a principle is, we are going to take, like the first derivative that we dealt before, but we are going to change, this is used to be y in the previous one, right? And we change to dy over dx, okay? It's as simple as that. So if you need to differentiate one more, then you need to change this with the second derivative, third derivative, fourth derivative, okay? So you need to go one by one, okay? Okay, now the questions, last questions, I think we haven't yet finished. So we have these equations, right? So let me review a little bit what we have. So you have the equations x and y in terms of variable t, the parametric. This is the parametric equations. And the first one is to prove whether the curve has a two tangents at this point, 3, 0. And find the equation. So find the equation of the tangent, or find the tangent line. Okay. So to find the tangent line, first we need to establish the relations on this point, 3, 0, with all the parametric. So this is first parametric, the second parametric is this, okay? And we conclude that this is our t. So we have two value of t, okay? Two value of t. So we get that at 3, 0, we have t equals square root of 3, and we have t equal negative square root of 3, okay? And then, as we mentioned in the previous slides, we take the first derivative, and this is just to remind you that whenever we have the dy over dx, in calculus, this means this is the tangent, okay? This is the tangent. So this is the tangent, okay? This is the tangent. And then we need to take the value and then put into our equations, okay? This equation. And we get that the value for the tangent is square root of 3, and the other part is negative square root of 3. So we have two lines, right? Two tangent lines. Okay, so basically this is the, maybe, let me write here, is to make sure that we are on the same page. So that this is the gradient, okay? The gradient. So this is basically just taking the line equations and the point is at 3, 0. So y is 0, right? So y minus 0, so it's just y, and then m depends on which one. When t is square root of 3, then this is square root of 3, x minus 3, right? Or maybe let me just make an arrow and make it there. Okay. Okay, that's the first question. So we established and showing that okay, we have these two lines, okay, these two tangent lines. Okay, the second questions now. Let me review the question here. Show or find points where tangent is horizontal or vertical. Okay, now we need to imagine if you, this is a pretty like a typical question in calculus. So to get to know or how to solve it, first is imagine the curve. Okay, imagine the curve. Well, this is just an illustration, okay, to see where our slope will be. Okay. Or maybe that's not a really good random curve. Let me, maybe that. Okay. So imagine that you have, let's say you have an asymptote here. Okay. And then if you take closely, we can take and we can observe the change in slope, right? And the slope will be horizontal, right? So we know that when we have increasing, this is a positive slope, right? And then somehow it gets 0, right? And then it's going down. This is a little bit of review on calculus 1, right? And it's negative slope, okay? And what about this one? If we want to observe as a slope, let's imagine that we have an asymptote here. So we say the slope is getting like infinite number, right? Infinity. So, and we know that this is horizontal and this is vertical. So we can say the tangent is getting horizontal when it's getting 0. The slope is 0. And it's getting vertical when it is undefined. Okay? Undefined. So this is, so the horizontal and vertical. So horizontal is when the dy over dx is getting 0. I think it's easy to calculate. And vertical is when dy over dx, we could say, is undefined. Okay, undefined. Okay, now if we break down this dy over dx into our parametric structures, okay, like we did in the previous slides, in the how we derive the parametric. we have these two components, right? dy dt and dx dt. Now from this part, we could figure out which one is 0, okay? Which one has a value, which one has 0. Okay? For this to be true, that this is 0, dy dx 0, then dy over dt should be 0, and this should be some value, right? So we need to make sure that this is equal to 0. Okay? And then for the vertical, we need to take this dy dx and define. So dy dt probably has some value, and dx dt is 0. Yes. Okay. So that's how we approach the horizontal and the vertical. So horizontal, when dy dt is 0 and dx dt is not 0, and vertical, when dy dt is not 0 and dx dt equal to 0. Okay. Let me write the equations, the question. X is t squared, right? Y is t cubed minus 3t. Okay. And then we can write each of them as dx dt is 2t, dy dt is 3t squared minus 3. I think I will take space here to make sure it's clear. Okay, so for horizontal, we could start with dy dt is 0. Then 3t squared minus 3 is equal to 0. Okay. I think this is just we could say that this is t squared equal 1, right? Or you could say t is plus minus 1, right? But it says that the question needs a point, right? So we need to plug in t to get the point. Okay? So when t is plus minus 1, so let me start with when t is 1. So we have x is 1, y is minus 2, right? When t is negative 1, x is 1, and y is negative 1, negative 1, negative 1, plus 3, right? So plus 2. Okay. So the point is 1, negative 2, and then 1, 2. That is for the horizontal. Okay, let me write here about here. And then do the same thing with the vertical. So vertical is dx dt equal to 0, or in our case, this is just 2t equal to 0, and we get that this is t equals 0. And if we plug in 0 for both x and y, we get that this will be 0, 0. Okay? So at 0, 0, this will be vertical. And at these 2 points here, the right side here, this will be the horizontal slope. Okay. So this step by step from the number 1 and then number 2 and then later number 3, they are building up how we are going to sketch the curve. Like we figure out which tangent that has probably loops, like it's twice going to the same point, and then which one is the horizontal slope, which one is vertical slope. Right? So at these points here, all these points, we could just take lines and then maybe imagine how the sketch will be. And maybe take some t, random t, and then just to make sure that we are on the right direction when we draw the parametric curve. Okay, now the next question is determine where the curve getting concave upward and concave downward. So basically the concavity, this will be related to the second derivative, right? The second derivative. So the second derivative is, we need to, let me take this as a, let me copy this to the next page, okay, copy. So we are going to find the concavity. Or the second derivative. So we get that dy over dx is this. Okay, and then the second derivative, let me write the structure. Okay. And then let me write okay. So ddt of the 3t squared minus 3 over 2t over 2t. So we need to differentiate this one first. I think I will just take the quotient rule directly. So 4t squared and then 60 and 2t, right, minus 3t squared minus 3 and 2, so 2 and then 3t squared minus 3, okay, and then divide by 2t, but I will directly write multiply with 2t like that, okay. I think we can cancel all this part, right? So this will be 60 squared minus 3t squared, or let me directly 3t squared plus 3, right, plus 3 over 4t squared, right? Okay. Now this is the second derivative. Okay. Now the concavity, this is related to the second derivative. Okay. So concavity upwards, concavity downwards. What's the deal with these two? The concavity upwards is when the second derivative is positive. Downwards is when the second derivative is less than 0 or negative. Okay? And how to differentiate visually? See, I'm usually used to say the C, U like that, C, D, okay? So to imagine upwards is u for upwards is like this, so the curve like this. Okay, I think it's easy to visualize. Okay, so it's supposed to be upwards like that and downwards like that. Okay, and then my suggestions always, okay, whenever you see inequality in any mathematics models, when you learn calculus 1 or even when you learn basic math, okay, or even when you review your high school notes, if you see any inequality, the best way to approach to avoid any mistake that you might have is just to draw line number. Okay? And what is the point for this line? Okay, now we know that from our restriction, what will happen in this formula? What is the most what number that makes this relation or make this second derivative maybe goes not really defined? Probably 0. So that 0 probably one number that we need to take here, and I think there's no other number that can disturb this formula, right? So you need to think, is there any number that will disturb this formula? Okay, maybe there will be discontinuity, something like that. Okay, maybe there will be asymptote. Okay, so that's why we are going to put 0 here. So this t equals 0. Okay, and then we try to check any numbers, and let's check whether it's positive or negative. Okay. Check 1, I think it's positive. If you check the negative, do you think negative will give you? So, oh, wait. This will be cube. Sorry about that. I forgot to multiply the squared with the t. That's why when I look here, when I put negative, wait, there's no negative. Okay, so if this cube, then if the negative here, it will be negative, right? You change all the system. So we have the negative and positive. So when t is positive, this will be concave upwards. When t is negative, this will be concave downwards. Okay, so from all this information, the tangent, the line equations, the vertical slope, horizontal slope, the concavity, how the curve will look like, whether it's downward or upwards at some point, it will help us to at least to draw the graph. I think we can try to draw. Okay, I try my best. Okay, I have the original picture, but I'm trying my best to draw here. Okay, so at the 0, 0, it's supposed to be. Let me just draw with dashed line to make sure that this is our vertical slope. Okay, and then at the let's say we have 1 is here. This is 2. This is -2. So at these 2 points, we have the horizontal, right? So maybe around here. Okay, and then don't forget the first question is the tangent at the 3, 0. So this is 3, so this should be the tangent. So there will be somewhere here, right? And somewhere there. Okay, for the tangent. Okay, now let me copy all this is the horizontal. Okay. Let me copy because the important one is we know which the t. Okay, so let me copy here to give you, and then vertical is 400, right? When t is 0. Okay, so we can pinpoint all the t. Okay. So this will be at 0 is when t is 0, and this is t is -1, this is t is 1. So it goes from here, I think it goes to here, and it goes here. Okay, and I think it will go going here, and then before this -1, maybe it is going here. Okay, I hope it's clear. So we can also make sure from the concavity that we have, when the t is positive, it's upwards. When t is positive, it's upwards. This is t positive, right? T equal 1. It's upwards, right? And when t is negative, here, -1 here, so around here, this area, this is going to be downwards, okay? But remember, sometimes because we deal with the parametric, okay, we are not seeing the curve as just x, y Cartesian. We add the t, okay? Sometimes when you deal with this, and maybe if you mix with the two-dimension space that you maybe before you prefer that way, maybe you will get confused. Okay? And after this, when we move to polar, you'll be, if you are not familiar with the system, you will get confused. Okay, you'll get confused. So please be careful. Okay. So let's connect all the point here. So probably it's going here. Okay, it's going here. Maybe I'm not really in a proportional, but I think still okay. Maybe going there. Okay, and maybe going there. Okay. Yeah, probably that is the curve with the arrow is going over there. Okay. Yeah, I need to draw bigger, but I think this is still okay. So if you if you read the textbook, perhaps you are going to read the information, and then you see the picture, like the whole picture for this graph. Okay? But if you didn't try, like which step is better to solve first, or how to sketch the curve, I think you can imagine. The build-up questions for this example is to help you draw the last curve. Okay? First, getting this tangent and getting all the slope here is helping you paving like a clear path, like from where direction should the parametric will go. Okay? So how do I know the directions? I know from the t. Okay? All the t that we get from all the informations. And of course, t is our let's say is our parameter that decide which one is which. Okay? Okay? From the t, that will decide the directions, the arrow. Okay? Now after this part, I will go thoroughly from this tangent, and then the integration part. So all the calculus method will be implemented. So this is the tangent, okay, derivative, and then integral. And then of course we already learned arc length, and surface area. But in terms of parametric. So really the foundations, the calculus 1 method, I hope you still remember. Okay, now we finish this part. I think finished, right?
So
Or no?
It's like time.
Yeah, you could think like time, okay? But it has like a negative. Ignore the negative part. It's like time, but it has negative. But it could be anything. It could be anything. Depends on how we view the parameter. We can take t as time to make us easy to understand. Like in physics, we have positions and time. I think that will be helpful. But actually, t can be anything. It can be anything. It is that parameter that will adjust the other two variable. Okay, now the next part is the integration. Okay, let me just write equations. Okay. If you would like to find out the area, okay, enclosed by this two parametric equations. If you would like to try, first you could eliminate the t if you want. Okay, let's try. So t is 1 plus y. Let me try this one. I think we could take this.
Why the t is 1 plus 1?
Oh, should be minus. Sorry. Okay, so you're not sleeping after lunch is really tough. So this will be 1 minus 2y plus y squared plus 2 minus 2y. Y squared minus 4y, right? Plus 3. this will be what? Y minus 1, right? Y minus 3, right? This is if we would like to try the eliminating parameter. So we know that these two, I think this is the same equation as yesterday, okay? So if you would like to know what kind of curve, okay, we can try to eliminate the parameter. And we get this just a normal parabola, right? Just a normal parabola. So
Sorry, isn't t equal y
okay, good. Why I'm writing 1 minus y? Okay, so you need to change all this stuff. No. Okay. Oh, nice. Nice. Is there any mistake? Is there any mistake again? Plus 1, 2y minus 2. Correct, right? This 1. Okay, right?
Yes.
Okay, right? Yes. You sure? Sure? Okay. So cancel out and we get this. Okay, so so at least we get that y is, yeah, we could write like this, right? So y is from -1 and 1. So it's just the, if we draw, maybe around here, -1 is, let's say -1 is here, 1 is there, right? And this will be like that, right? Why it's not symmetry? Just a little bit, okay. Okay, let's say, okay, we are going to take t, okay, from 1 to 4, okay. If we take this and if we translate to x, this will equal to, if t is 1, this will be 3, right? If this is 4, this is 16. 16 plus 8. What is that? 22. Why the number seems big? Oh, I think because I plus this. Easier if this minus, but let's say this is what we have. This is what we have. So we're going to evaluate from 3. Let's say 22 is here. Okay. So to give you illustrations, let's say we are going to evaluate in the x. Okay. If we would like to evaluate in the x, then our equations, we need to take this into either we have plus square root of x plus 1 or negative. Okay, right? Okay. Now if we are going to evaluate from 3 to 22, okay, let's say we are going just to evaluate the top one, okay, this area, okay, which means the area, usually we take a to b, okay, and then y dx, right? If y is function of x, or if we usually write fx dx like that, okay? Or maybe just y, okay? Easy to follow from the previous page. So that means if we take this 3 to 22 and then we evaluate this, then this will be our area, the top area, right? The top area. Okay. But now, okay, if we can perhaps change this y and dx, okay, and make it into dt. Pretty similar from what we have in the chain rule. So in the chain rule, previously when we describe the tangent, and when we describe the tangent, when we have dy dt, we could take this as this chain rule, right? Okay. Now look at this dx, okay? Okay. If we are going to take this divide with dt, we need to also multiply with dt, okay? And then if this y, okay, if this y is also a function of t, then perhaps we could also approach this with t1 and t2. Okay. And that is precisely what is happening in integrations. Okay. So the integration formula, area for definite integral in parametric curves. We could state first is the usual or the original equations, these integrations from a to b y dx, okay, and equal integrations. I will use the same symbols in the textbook. It's using alpha and beta. That's for the t. Okay. And this is g of t because y is g of t, and dx is f prime t. Or if you would like to write with the same symbols with just y of the t, this is also okay. So t is from alpha to beta, y is g of t, x is f of t. So this is for the area. Okay. Okay.
I'm so fresh.
Okay. Okay, back to the class. Okay. Okay, back to the reality. Okay, so this is for integral. Okay, this is for integral. Integrations in parametric. Okay, I will give you all like integrations, the arc length, the surface area, and then we can have our practice. Okay, so the next one is the arc length. Okay, arc length is still fresh. We still did it last week, right? So if you remember, the way to prove or not to prove, the way to visualize easily how the formula will be for the arc length is just to draw a random curve. Okay. Draw some slope, like small slope, to note that this will be, we name as a dl. This is dx, this is dy. And we can just using the Pythagorean formula to see the relations between these three. So dl squared is dx squared plus dy squared. And then dl is square root of this. Okay, and then we could take this, like if we take the integration both sides, the formula, and if you take factor the dx, this will be 1 plus dy over dx squared and then dx, right? Let's say this is a to b. Okay, let's say that's our usual arc length. Okay. Now arc length in parametric. Okay. Now in parametric, suppose that this is the same dl that we have, or maybe let me write the dl first. dl is square root of okay. Now let's say we are going to integrate this. So this will be, now the next step is we are going to introduce the dt. Okay, so from this variable we are going to introduce dt the same way we introduced in the previous integration. So we are going to do the chain rule. So we are going to, so both dy and dx, we are going to take this approach. So we are multiplying with this, okay. And also the same thing with dx. Okay, and then we factor out dt. Okay, and then lastly, we get that this is L integration. We could say that this will be y prime t plus x prime t, and then dt. Let's say from alpha to beta. Alpha beta is our t. Okay. I think I will move this part going here, this part going here, so this is more, I think, better. So that's for arc length. Okay, still arc length, we also can represent with the function, the arc length function. So arc length functions, we could write. So now it's alpha. The variable now for the function is t. Okay, so we need to have another variable for the arc length function. So usually we are going to take du. Okay. This is basically the same thing. These two. The difference is this is the whole thing here. The whole integration is a function. So this will be another variable that will describe the function itself. Okay, usually in the previous week we have the x here, right? So now it's t because in the parametric. So most of the case, if you clearly observe, the parametric is just we are all the techniques all the same. What we are going to have here is we one by one we see how we like it's like a template, So we have a template of the techniques, and we could just change the dimension, change the space, change the space. So how we change the space? By adding the additional variable t. And after some review, I think chapter 12, I think I only maybe focus on two sections, last two sections. So I will skip most of the part. Okay? So I will maybe giving you just a brief intro and then directly go to the last two sections. Yeah. And for the parametric, I think I will skip the conic sections and the conic sections, and the polar conics, Okay. Instead, I will just give you maybe just one additional content on the conic sections, just short, maybe like a video. Because basically the conic sections, it doesn't really cover much topics in our course. And I will just focus more on the calculus part.
Where is the u?
du is the another additional variable. So if you remember correctly in arc length function, we have a constant x, right, and then t. Now we have t and then another one u, additional variable. Okay, this is just to help you to integrate, because if you integrate, well, technically you could take this with dt, but you will have a problem when you deal with another t here, and you will confuse on the definition of the variable. So you need to add another variable. Why we need to add? Why we need to add? That's the question, right? Why there's so many variables? So basically, why we need to add this du is because we want to operate this. If we operate this with the dt, we cannot do that because now in arc length functions, t is our variable, not our supposed to be a constant, right? So we are going, because we are going to define all of this into one variable t. That's why we cannot operate this with t, because t is supposed to be the last part that we conduct. Okay, if you can process that logic. Okay, but however, if you don't understand that, that's okay. Doesn't matter. Okay, but you will see that. You will see that. Okay, now one more. Okay, one more. So arc length functions, and the surface area. Now this is, I think there is one like really important note on the surface area. So let me write curve C defined by these two parametric and then all the functions can be derived or continuous. Let's say continuous, so no problem in the curve itself. The function for y is positive, so we are make sure that it's on on the top, okay, the positive one. And then what we need to make sure is, let me write here, the curve C traverse or move exactly once as the increase. Okay, this is the important one. Increase from alpha to beta. So this is, I will underline this with red color. Okay. Okay, if C rotated about x-axis, then the surface, the resulting surface S is 2 pi y ds, right? And simply the ds, because it's in parametric, of course it will be in dt. Okay. So no worry on finding which one, dx or dy. This is supposed to be dt. Yeah, of course, if you rotate C, so if C rotated about y-axis, then S, so we just change to x. Let me write just ds, okay? ds is the same. ds is the same. So to calculate the surface area, okay, well, why we need to take care of the important notes here? We need to make sure that the curve traverses exactly once. If you have like twice that, or maybe it has a loop, then perhaps we need to change the t to make sure that our surface is just traverse one. Because, for example, if you remember, like I think last week or yesterday, there are sometimes the curve that maybe it's like circling the same graph, right? Circle the same graph. If you use the that t for that same graph, there will be some error in its calculation. Okay, if you could imagine that. Okay? So that's why we need to make sure that it is exactly once. Okay? So if you see like maybe it's twice, so maybe you need to change the t and make sure it's traverse all the points once. Okay? Make sure that. Okay. I think we can have some example, some practice, and perhaps we still need to have like more discussions next week. Maybe we can have the review for some couple of questions and then move to another subject. I put in the Moodle some introduction on the polar. So there are like a short video, I think 10 to 15 minutes long each video. The video is about polar coordinates. The polar coordinates, the polar curves, how to draw, how to graph, and how to visualize. And I think the last video will show you how to draw the polar curves from the polar equations. Okay? So there will be some formula and how to define those formula in the graph. Okay? Okay? So I think it's quite easy listening video. So I hope you could watch that and learn more. Okay? And then if you want, I think they have like more videos in their own YouTube channel, and I think you can just scroll and just choose which one you like. Okay? And I think that's really helpful. That's really helpful. That is just for intro for the polar system. So when we enter the polar, and I think next week we enter the polar, I will just mention the important one, okay? The important one, and then some summary. Okay? So we can directly go to the calculus part. Because we are not really discuss much on the polar itself. Okay? So we need to take the polar in calculus terms. Okay, let's say we are going to have example. If I have, okay. So we have this parametric already with the curve. So find the area. Find the area enclosed by the curve and x-axis. That's the question. Maybe giving you some time to think and perhaps to look on your notes. Remember, in parametric, we still deal with the x and y. We still deal with the x and y usual Cartesian. Okay? And the way you solve this, basically, similar with our original calculus one. Okay? But the difference is when we are in the computations in the middle process, we are going to switch to dt. So let's say we have this curve. Okay. But to imagine how the point here is on the x-axis, right? Which means that we could imagine what kind of point here. So we could take that into our x system, our x-axis, and then from there we could switch to t. Okay. So find the intersections first when equals 0, right? Like usually we did. So first step, finding the intersection. So this intersection is when y is 0, right? Y is 0. So imagine y is 0, we get t, right? We get t. And from that t, we get x. So at least we get x here. Or if you would like to directly take t and calculate it, also fine. The first intersection. So find when y equals 0, or we take 2 minus t. So t is 0 and t is 2. Okay. So when t is 0, x is 1, and when t is 2, x is 9. So this point here is 1 and 9. So area is from x equal 1, x equal 9. I will write with x to make sure that when we shift to t, you understand. Okay? Let me write the complete formula. Usually we write yt minus yb. Okay. T is for top, B is for bottom. If we have two curves, then the top minus the bottom one, if you remember the calculus one, and then the x, right? Okay. Now we need to change to t. Okay, change to t. So change to t. Well, you could skip this one if you want to directly to t, but this is just to show you how this steps is not really different from what we have learned before. Okay. So now t is from t0 from t equal 2. This is y of t. The y bottom is just y equals 0, so it's 0. And then we could write this is dx dt, right? I will write one by one, okay, all the process. So this is 0, 2. Y of t is 2t minus t squared. Okay. Dx dt is, where is dx dt? Here. So dx dt is 3t squared. Okay. So this will be 3t squared and then dt. Okay. I will factor out 3 and then multiply all together. 2t cubed minus dt with power of 4. Okay. dt. Now 3 multiply with 1 over 4, but it's 2 over 4, so 1 over 2. Now we need to calculate. So 3 16 by 2 is 8 minus 32 over 5, right? 40 minus 32 is 8. 8 by 3 is 24. Okay, that's the answer. Okay, any questions? No questions? I think you could, if you got the way the parametric does in calculus, I think you could directly write from here. Directly write here. I think it's quite understandable if you write from here. If you are not sure how the process, I think you could look up the first one here. Okay. It's taking like usual integrations. Okay, let's go to the next question. Okay, let's go to the next question. The next question is find exact length of curve. Length of the curve. Yeah, so sleepy. Agree. But that's the nature for if you eat carbohydrate, like the dense carbohydrate. You know carbohydrate? C, right? It's like they have a long chain. Well, it is to show you that it really takes time to break down all those bonds. Well, it's really change to chemistry. Yeah, it takes time, and that's why, because your metabolism process all those digestion stuff. That's why you feel sleepy. And another thing to add is the oxygen. Also, when you are maybe need more oxygen, you will take right? Because your brain needs oxygen. I think in the middle of the day, if you have a chance to sleep, just like for 20 to 30 minutes, I think that's really.
You got a bit more.
Really, I think 30 minutes, if you sleep really good quality sleep, it's enough. Just for additional, for the rest of your day, okay? I think 30 minutes is enough. I forgot the name, but it's from the Indian, not Indian, American Indian, American Indian. They sleep like a few hours, but they have good quality sleep. I forgot the technique's name, but yeah, you can try at that as well. Okay, now here is the exact length of the curve. So which means the first thing we are going to do when we have x and y in terms of parametric t, then we are going to find the first derivative for each one. Right? This will be 2, right? Okay, next is we take this squared. Well, I think I'll write here so that I can make some addition here. So plus and this will be okay. I think we can solve for a while. This is e with power of 2t minus 2 e with power of t and plus 1. Then this will be 4 and then cancel 2 and e t right there, right? And this will be plus 2 plus 1, okay? And as I mentioned, whenever you deal with the arc length or surface area that requires the square root, what you need to do is you observe the equation. Can you make a squared form, okay, from this part? So you can get like e, t, and it has 2. Perhaps this is a quadratic, right? Quadratic formula. And yes, we can make the squared form. We can make the squared form. So this will be the squared form of this, right? So then when we are going to take this result and squared then this will be e power of t plus 1. Okay, so the length, the so-called length from 0 to 2 is just e to the power of t plus 1. Maybe take the absolute value to make sure that this is correct. Well, you may skip that one. Okay, you can make it directly positive because e plus 1 is, of course, that will be positive value, right? So we don't need to worry about the negative part. And then take integrations. This will be e t plus t from 0 to 2. So e t plus 2 and then minus 1, or this is e t plus 1. Okay, I think should be okay, right? Okay, I think I will stop up until here. I will give you, I think, more exercise as we continue to the next section, which is the polar. And don't forget to watch the video that I put in the Moodle. Why? I thought this is 2, but what I'm writing is T. Yeah. I thought I was writing 2 with T. Okay, any questions? No? Then it's time for the... Let me check first.